Hi everyone, so today we're going to try to solve an algebraic problem where we have to isolate for x. So for instance, letter A, it says a over b is equal to x over y. So the first step when you have a proportion like this, when I say proportion, it's a ratio with an equal sign. And so basically it's a fraction equals another fraction. So when you have a proportion, you have to cross multiply first. By that, I mean we multiply a, the numerator of the first fraction, to the denominator of the second fraction. So that becomes a multiplied by y, or a times y, is equal to the denominator of the first and the numerator of the second. So that's b over x times x, sorry. So after cross multiplying, remember we have to solve for x. So our second step is to move over b to the other side so we can completely isolate x. So by doing that, our final answer should be a times y over b. Remember, when we do a moving over, or when we transfer one variable from the right of the equation sign to the left, we have to do the opposite operation use. So as you can see, the operation used for b on the right side is multiplication because it's b times x. So when you move it over to the left side, you have to do the opposite operation, which is division. So it becomes a times y over b. So right after doing that, we just have to put equals x. So basically, once you isolated b to the other side, you have isolated x. So the final answer for letter A should be a times y over b. So let's try another kind of problem. So let's say you just have one variable equals a ratio. So basically the difference between letter A and letter B is that you only have one variable instead of having two fractions for both sides of the equation symbol. So that is a very straightforward and one-step solution only. So when you have this kind of problem, you just have to move over z to the other side because you have to completely isolate x. So when you do that, the final answer would be n times z. So remember, when you move over a variable from one side to the other, you have to use the operation which is opposite to what you're using on the other side. So on the right side, z is divided, right? So when you move it over, it has to be multiplied. So that gives us n times z equals x. So we have completely isolated x. Right? So let's try another kind of problem. So for letter C, the x variable, which is the main goal for us to isolate, is now on the denominator side, right? On the denominator area of the fraction. So let's see what we have to do. So again, if you are given a proportion such as this, you have to, what was that? Cross multiply. That's right. So cross multiply. So when you cross multiply them, you will have r times x. So remember, once again, when you do moving over, cross multiplication, you have to basically do the opposite of what you're doing, right? Do the opposite operation. So that's why we call it cross multiplying, right? So r times x equals 5 times s. So again, our main goal is to isolate x. Therefore, the easiest way to do that is to move over r to the other side. So because it is multiplied on the left side, once you move it over to the right side, it becomes divided. So 5 times s over r. There you go. So that's pretty straightforward. Now let's try letter D. So most of you may be familiar with this equation. It's the Pythagorean theorem equation. So when you have that kind of equation where you squared all your variables and it's written this way, b squared minus a squared equals x squared, you have to remember first what variables should be isolated from the rest of the variables. In this case, x has to be isolated. So it's very easy, all right? So you have to remember, how do we make x squared x, right? So if we write it as x squared, how do we make it an x only? So if we remember our exponent rule, x squared is equal to x times x, right? So basically x squared is 1x, 2x, right? So to make it a single x, we have to omit the square element of our x squared, right? So to do that, we have to also affect the other variables. So if we try to omit the x squared, we also have to omit the square from the other variables. And the way to do that is to write a square symbol for all of the variables, right? So when we square root our x squared, we have x. Once we square root our b squared, we have b. Square root our a squared, we have a. So therefore, isolating x is square root of b squared minus a squared. Does that make sense? I hope it does, right? So basically going back to the step that we used for solving letter D, we have to remember that our main goal is to isolate x. So therefore, we have to square root our x squared to find the root, right, which is x. And when we square root x squared, we have to square root the rest of the variables as well. In this case, the variables on the left side. So our final answer should be the square root of b squared minus a squared. All right, so let's try letter E. In this case, we're trying to, if you're familiar with it, this is a problem for trigonometry function, right? So let me just clear up some space. Clear up some space for letter E. So this will be our last problem. So now it's a little bit on the unique side because we're using trigonometry function, which is the sine function in this case. But we it's not difficult at all. It's pretty simple. We just have to remember that the main thing to do is basically isolate the x. So it doesn't matter what variables you use, as long as you know what the end goal is, which is to isolate x. And in algebra, it's pretty straightforward. You just have to follow the steps and make sure that when you're moving over the different variables, you maintain the basic rule, which is when you move it over, always use the opposite operation. So in this case, what we have to do to completely isolate x is to move over this term, which is sine A, right? That's the very quick and straightforward way of isolating x. We don't have to move anything else because x is here, right? X is open to be isolated. So once we have decided to do that, we move over sine A to the other side. And remember, the operation we used on the left side for sine A is multiplication. So once we move it over, we have to divide, right? So x is equal to b sine b. So basically I'm copying the right side of the equation and put the moved over term, which is sine a. So that's it. It's a one-step solution for letter E. Although the terms and the variables used is a little bit unique in such a way that we're using trigonometry function, but we always retain the fact that basically what we're doing is just isolating x using the basic element of algebra, which is just to move over and retaining the rule that when we move over, always use the opposite operation. All right, so that's it for today. I'll see you soon for another video.